Have you ever just stopped and wondered, is there a final boundary to what we can know? I'm not talking about the edge of the observable universe, but a really fundamental limit to reality itself. Well, today we're going to explore the very edges of physics, of mathematics, and yeah, even our own minds, to see where the solid ground of science just stops. Okay, so let's just jump right in with a question that feels like it's straight out of a movie, but is actually debated seriously by top scientists and philosophers. Are we living inside some giant, super advanced computer simulation? It is a totally mind-bending idea, right? That our entire reality is just code. But what if we could actually prove it, one way or the other? Well, it turns out new research points to a surprisingly firm answer. Nope. The simulation idea isn't just unlikely, it seems to be mathematically impossible. And the reason why? Well, that takes us deep into the very nature of how reality is put together. To really get our heads around this, we have to start by looking at the, let's call them, glitches in our own universe. Our world feels solid, predictable. Cause and effect, those are the rules. But when physicists zoom way, way down to the tiniest quantum scales, they found that reality starts behaving in ways that are, well, they're just deeply, deeply strange. And this right here really shows you the split. On one side, you've got classical physics, the world we live in, where a ball follows a nice, clear path when you throw it. But on the other side, you have the quantum world, and down there, it's all about probability. Particles can be in many places at once, and get this, the very act of looking at something actually changes what it's doing. It's like a whole different rulebook for reality. And if you want to know just how strange it gets, look no further than the quantum Cheshire cat experiment. Scientists actually managed to separate a neutron from one of its own properties, its magnetic spin. They literally sent the particle down one path and its spin down another. I mean, that's just like the cat from Alice in Wonderland walking away, leaving its grin behind. It makes you ask this totally wild question. What even is an object if you can take it apart like that? So, these glitches in the physical world are really just the beginning. If the hardware of reality is this bizarre, what does that say about the software? The fundamental mathematical language it runs on. Well, this brings us to one of the most mind-blowing discoveries in the history of logic. Back in the 1930s, this logician, Kurt Gödel, dropped an absolute bombshell on the world of math. He proved that any logical system, from simple counting all the way up to the crazy complex math that describes our universe, is fundamentally incomplete. What that means is there will always be things that are true, but that you can never, ever prove are true using the rules of that system. It's not that we're not smart enough. It's a limit that's hardwired into logic itself. The logic here is a bit of a brain twister. Think about the sentence. This statement is unprovable. Okay, so if you could somehow prove it was true, well then the statement itself would be false, right? Which is a total contradiction. So the only way for the system to not break down is for that statement to be true, but unprovable. And that means there are truths out there that you just can't get to with a step-by-step computational process. So here's the crucial point. When physicists talk about a theory of everything, they're usually talking about one set of equations to describe all of the forces. But Gödel's theorem throws a huge wrench in the idea of a complete formal system, a kind of mathematical source code for the universe that could prove everything there is to know. So how does this all circle back to the simulation idea? Well, a computer simulation is the ultimate algorithmic system. It runs completely on a set of defined rules. But Gödel shows us that reality has this deeper layer. As the physicist Lawrence Krauss says, a complete description needs non-algorithmic understanding. Basically, there are parts of our universe that you just can't capture with code. And if reality contains truths that can't be computed, then it can't be a computer program. Simple as that. So, you see, the limits of reality aren't just out there in deep space or in some abstract math equation. Maybe the most profound, the most baffling limit is the one staring right back at us from the mirror. Science is getting amazing at solving what the philosopher David Chalmers calls the easy problems of consciousness. Mapping how the brain works. But the hard problem, that's a different beast entirely. It's the question of why. Why does all of this information processing feel like anything at all from the inside? Why does the color red look red? There is nothing in physics that even begins to explain our own subjective experience. And listen, this isn't some fringe out there idea. A huge survey from 2020 found that almost 2/3 of professional philosophers agree that the hard problem is a real, legitimate, unsolved mystery. It's a mainstream puzzle at the heart of science. And the implication of this is just enormous. Think about it. If our consciousness, our inner feeling of just being, can't be boiled down to a bunch of neurons firing, then physicalism, the whole idea that the physical world is all there is, could actually be wrong. It suggests there's some fundamental piece of reality that our current science just can't get its hands on. Okay, so let's recap. We've got a universe that's built on unprovable truths, and it's home to a consciousness that we can't physically explain. Now, let's pull these threads together and look at how this simple act of observing might actually be what creates the universe. Check out this wild thought experiment. A scientist is inside a sealed lab, and she measures a quantum particle. From her point of view, the result is set. Let's say its spin is up. But to our friend standing outside the lab, the entire lab, including the scientist inside it, is now in a quantum superposition, a blur of every possible outcome at once. And here's the truly mind-bending part. Quantum mechanics says both of them are right. Reality, it seems, can actually be different depending on who's looking. What this all points to is this massive shift in thinking. Maybe reality isn't this fixed, objective thing that's just out there for us to find. Maybe, just maybe, reality is something that we actually help create, and it only snaps into focus through the act of us interacting with it. So, after all that, where does this journey leave us? We started with a pretty straightforward question: are we in a simulation? But the answer has taken us to the absolute foundations of truth, consciousness, and the very fabric of reality itself. What we've seen are three huge fundamental limits: a mathematical limit, where some truths are just forever out of reach; a conscious limit, where our own inner experience defies any physical explanation; and a physical limit, where reality itself seems to change depending on who's watching. The picture of the universe isn't just unfinished, it seems like it's designed to be unfinished. And that leaves us with one final, really provocative thought to chew on. We always think of ourselves as explorers, finding a universe that was already here. But what if we've got it completely backwards? What if the universe is just this sea of potential, and it's our conscious observation that turns all those possibilities into the solid reality we see? What if the universe actually needs us to exist?